So configuring the 8400 for a single discharge, the first thing we're going to do is we're going to go to setup. Okay, we're going to verify the date and time are correct. They're not in this instance, so let's dial this down to what it actually needs to be. Oh, it is 2021. Duh. Time we got 9:37. If you hold down the keys, it will scroll. If you press the key once, it'll increase or decrease by one value. And then every time you hit the select key, it moves to the next function, right? So the select key is like your arrow key. So we're at 9:37. The longer you hold the key down, the faster it'll scroll. So input type is touch screen, battery low. We're going to select this to pause so that if we get an AC failure, it's going to stop the test, but we're going to be able to restart it and continue to accumulate taking data. Our battery order is from the positive to the negative, so increment from group positive.
Okay.
And then we're communicating on frequency number 1.
It's a tough life you guys have, you know?
So we'll exit out of that setup screen. That automatically saves any changes that you make in the setup screen. Automatically saves when you exit out of the screen. We're going to go into discharge. And now you can see we're in preset parameter number 1. And if you use the parameter plus and minus, you can have up to 30 different presets programmed into the 8400 unit. So once you've got a preset test set up, you just have to select that preset and press start, and it's going to run that test. So in this instance, we're going to go into parameter 1, and we're going to modify it to be the test that we will actually want to run. We're testing an HX540 high rate battery, and we're going to be doing a 1-hour test. So what we did is we went to the manufacturer's data sheet. We looked for constant current discharge rates. We found that that battery is rated to 1.75 volts per cell at 97.3 amps for 1 hour. So that's what we're going to set our test up as our baseline reference data is going to be 97 amps for 1 hour down to 1.75 volts per cell, 10.5 volts per battery block, 105.0 volts DC for our group low voltage shutdown. So to modify any of the parameters, we're in a preset. We hit the modify key. Again, my select is my arrow key to choose which value I'm on. And then my plus and minus keys add or decrease from the value that's displayed on the screen. So my test I'm running 97 amp hours. That's 1 hour, 97 amps is going to be 97 amp hours.
Right.
If it was 50 amps for 3 hours, my amp hour rate would be 150 amp hours, because that's the total that I'm pulling from the battery.
Okay.
And my hour rate would be the 3 hour rate, because that's the value that came from the battery data sheet.
Right. Okay.
That's not how long my test is going to run. That's not when it's going to shut down. That's what the battery's 100% rating at that rate of discharge from the performance data is.
Okay.
So I'm set at 97 amp hours. I'm going to come down this and I'm going to change it to the 1 hour discharge rate, because that's what I pulled from the data sheet, 97 amps for 1 hour. I'm going to save data. I usually save data every 10 minutes on a 1 hour test. On an 8 hour test, I'm only going to save data every 15 minutes.
Okay.
You can save data every minute if you want, but it just makes for a huge, gigantic report that can be 30 pages long. So over an hour, this is going to give me a starting point and ending voltage, and it's going to give me 12 voltage levels during the performance of that test.
Okay.
So every 5 minutes is okay. I'm doing constant current discharge. So I want to make sure my test mode is in constant current. Power set is blacked out or grayed out because I'm not in constant KW. AC error. I'm going to scroll down and that AC error, whoops. I'm going to put that to pause, the same thing that I did in the setup screen. I'm testing one string. So I can test multiple strings of batteries at the same time. The wireless modules will connect to one string and two strings. And then I just set that value to 2 if I'm testing 2 batteries at the same time. If I'm testing 2 batteries at the same time, I've got to go back and I've got to remember amp hour rate doesn't change, hour rate doesn't change because the batteries are still rated the same, but my discharge current, my test current, I've got to double because now I'm pulling
2 strings.
2 strings, and each string I want to run at its rating. So test time, this is a shutdown parameter. So I'm running a 1-hour test, but I want to program this test to 1 hour and 30 minutes so that if the battery's more than 100% capacity, I let the load bank run long enough to capture what the true capacity is. My test current, I pulled that off the data sheet. That was 97.3 amps. Test capacity. How many amp hours do I want to allow to come out of this battery before the test self-terminates? I typically set this at 125% or 130%. Valve regulated, I'll set at 125%. Flooded cells, I'll set it for 130%. So my test capacity, 97 amp hours. I'm going to dial that test capacity up to 125. Battery sum, I'm testing 10 12-volt blocks. So we're going to set battery sum at 10. My group low voltage is my 1.75 volts per cell times 6 cells per 12-volt block gets me to 10.5 volts per battery times 10 batteries gets me to 105.0 volts DC. So I'm going to drive that all the way up to 105.0. The nice thing about having all the preset parameter screens is once I get the test set up, I no longer have to hold the buttons to dial all the way up through the values.
Right.
Battery low voltage. If I'm using the wireless modules, battery low voltage is the voltage that I want that module or battery to alarm at,
Okay.
not to stop the test at. So in this instance, 12-volt block batteries, 1.75 volts per cell. My battery low voltage is going to be 10.5. My number of battery lows is how many batteries have to hit that 10.5 level before the test automatically stops. So what happens in capacity testing is people will set this at 1 And as soon as the first battery hits 10.5 volts, it stops the test. What I've done is I've measured the capacity of that one battery, but I haven't measured the
String as a
capacity
whole.
of the string as a whole or all the other batteries that are in that string. So I usually set number of battery lows to 4 if I'm doing 12 volt block batteries, and I'll set it to 6 or 8 if I'm doing individual 2 volt cells. That way a number of cells can come down below that target value. As long as my group voltage is still above that 105, I want the test to continue to run until that 105 is the only parameter that shuts my test down.
Right.
So because we're not using the wireless modules for this test, I'm going to set number of battery lows all the way up to 10 equal to the number of batteries that we're testing. So it's going to ignore us not having the wireless modules connected to the system. Now once I get all of these parameters set, I'm going to hit the apply button. It's going to overwrite that preset. So now if I go back out, I go back into discharge, all those values that I just programmed are now what show up as preset number 1. And they're going to stay in memory as preset 1 until I modify or write over the top of them. So now that I've got the load bank set up and I've got all my parameters programmed, the next thing is to connect the battery to the load bank. I'm going to measure the battery string at the connector that I'm connecting to. Right now I'm at 133.5. I've got 10 blocks, so each block should be at 13.35 roughly, just to give me an idea of where I'm starting. Now if I'm using the wireless modules, they're going to appear on the display and it's going to tell me what those voltages are. But because I'm not using the wireless modules, I can come in here and I can start looking at the batteries, and I'm looking to make sure these are all somewhere around that 13.35, 1/10 of what I measured at the connector. So 1334, 1334, 1340. This one's a little bit higher. Immediately looking at the battery, I can see, oh, different date code. This battery's been replaced. It's not the same age as the others. That would explain why that voltage is slightly higher. On my machine, I may see this battery run a little bit differently than the others because it's not the same age, it's not the same date code, it may have been in a different system, it may be a replacement battery. But this gives me a starting point by checking overall voltage against the individual voltages, what I should keep an eye on while the test is running. So as part of our safety, we always check connectors before we connect an Anderson connector together. So we always measure that we've got the correct polarity on all these connectors before we connect any battery system to any charger, or any load bank, or anything like that. So we'll go in, and on the load bank side right now, I don't have any voltage because the load bank isn't a source of power. The load bank only consumes power. When I connect the Anderson connector together, I want to verify cable colors. Red is positive, black is negative. They're marked on the Anderson connectors, but I also want to go back to the other end of the cables and I want to verify my red cable actually lands on the main positive terminal of the battery. My black cable actually lands on the main negative terminal of the battery. So that way when I connect this connector together, I know that my polarities are correct. There's no load, no power here. I'm not going to get an arc or have a problem when I make that Anderson connector to connect to the load bank. Now that my DC battery is connected into my load bank equipment, I come over to the unit, I press the start button, I get a summary screen at the top of the screen. Group voltage, current, total power being consumed, number of battery lows, test time as the time progresses, and amp hours removed. So it'll cumulatively add up the amp hours removed from the battery. As soon as I turn on F0 switch, I see my group voltage of my battery system show up on the load bank. What that does is that connects the battery to the load bank so the load bank can start measuring the values. If I had the individual modules, I could hit the battery key and I could see those individual voltages by pressing that battery key. I hit the chart button and they would be in a graphical format. I can go back and I can hit the parameter screen and I can review my test parameters, make sure they're set correctly. I can modify them if needed. If not, I can just exit back out, back into discharge, my summary screen. I'm gonna press the start button. You're gonna hear the fans on the 8400 turn on to start airflow for cooling the load bank before the load actually gets applied. I get an acknowledgement to make sure that the fans are running. I hit OK. It's going to tell me to turn on the F1 switch. As soon as I turn this switch on, the load bank is going to start gating the IGBTs inside. It's going to start loading up the battery. We'll see voltage collapse. We'll see current rise. And it'll stabilize out at that 97 amps that we programmed it for. So I turn on the F1 switch. I press OK. The load bank starts. I see my battery voltage start to collapse as the current starts to build up on the load bank. And that's that coupe de foie in the battery discharge curve as the chemistry tries to catch up with the demand of the current on the battery. Within the first 1 to 3 minutes, I should see a slight recovery in the voltage as the voltage comes back up as the chemistry catches back up with the load. And then from that point on, I'll see a stable DC voltage over the course of my test. Now you can see my DC voltage is starting to climb back up. It went from 120 to 121, 121.5, 121.6. So that recovery has already happened now that the load is steady at that 97.3 amps. On the display, I'm going to see my current. I'm going to see my amp hours removed. I'm going to see my highest voltage and my lowest voltage, green and red, so that I can walk by the machine and at a glance get an idea of what the condition of the cells are. I can press the battery key and I can go in and look at those individual values as the test is running. I can go back to table view, view them all on the table. Hitting the exit key there takes me back to the main screen or the discharge screen. Hitting the exit key here stops the test.
Okay.
So in an emergency, I can stop the test simply by pressing the exit button. The unit has 4 automatic built-in shutdowns. If it reaches test time, test capacity, group low voltage, or number of cell low voltages times the number of low cells, it will automatically terminate the test. It has heat sink thermocouple or thermistors. So if the heat sinks reach 40 degrees Celsius, it'll give me a high temperature alarm and it'll automatically stop the test on the overtemperature. Now the test is going to run for 1 hour and 30 minutes that we programmed. It's going to run to 1.105.0 volts for the entire battery system. And we'll be able to measure the amount of time that the battery lasts until it hits that 105. And we want that group low voltage to be the shutdown parameter that terminates the test.